conversation. Let me introduce myself. My name is Polina Leon. I'm Chief Sustainability Officer of Rosatom Atomic State Corporation of Russia. And here with me is my colleague, Boris Arseev, who is Deputy Head of International Business of Rosatom. And we also have our two speakers online, who are Paul Wynn, Chairman and Director General of the International Irradiation Association, and also we have online Giovanni Gargoni, who is Director General of Regional Healthcare and Social Affairs Agency of Puglia, Italy. Hello, colleagues. Thank you for joining us. And actually, today morning we had a very interesting, very interesting conversation about climate effects of nuclear energy, and even we have discussed broader effects of nuclear energy as social effects and infrastructure effects, together with complexity of questions of attracting financing for our nuclear power plant projects. But the thing is that nuclear industry is much more wider than only energy one, and so we today at this session we are going to discuss on how nuclear technologies, how nuclear appliances can help to deal with global problems, and we mean 17 Sustainable Development Goals, which cover different challenges. So, for example, human health or hunger problem, which are still with us and still are very sound in some regions. Probably I will facilitate our discussion a little bit. And so my first question for Boris is, what about sustainable goal number 2? Let's start with this one. I mean, zero hunger. How can nuclear technologies can help to deal with that?
Polina, thank you for introduction. Once again, I am Boris Arseev. I'm responsible for business development at Rosatom. And thank you. I was too fast.
Wow.
First of all, dear friends, nuclear technologies contribute to the quality of life. And it's terrifying that today, in the 21st century, the humanity is still struggling against the so interesting human problems like hunger, the lack of drinking water, and access to health care. But really, it's true. And today, the Sustainable Development Goals are covering these problems, and we as Rosatom think a lot about that, and not only think and speak, we are doing a lot. And may I share some kind of information with you? For example, every year people throw away 1.3 billion tons of food. Due to expiration date, or because the product was caused by bacteria. Is it a lot or no? What do you think? Basically, it's 1/3 of the food production over the world annually. It's a huge amount. And the this irrational use of food is extremely urgent issue for some countries in the world, especially speaking about regions as Africa, South and Southeast Asia, and maybe other countries. But it's really very important in a huge amount. And the problem is not only in food production. It depends how was organized the long-term storage of this food. Because during the storage or during the transportation, it's a huge impact from some kind of some bacteria. And today, as Rosatom, we have some methods that we develop in that method. It's called cold pasteurization. What it means? It's ionizing radiation treatment. It helps to save the products during being in storage and during transportation. And let me share with you some digits that cold pasteurization allows to increase the shelf life from 2 to 10 times. And it allows to destroy up to 99% of malignant bacteria and viruses.
Wow, I think that that could be also used for our masks.
Yeah, it's very important because cold pasteurization kills pathogenic microorganisms and larvae of harmful insects, preserving the natural properties of the product. And by the way, food irradiation is used in more than 60 countries. And every year, 500,000 tons are tons of food are processed every year in different countries. Generally, of course, it's a small amount. It's it's a modest but extremely important contribution to nuclear technologies to the fight against hunger. However, the shelf life of food is not the only issue that need to be addressed. Insect pests. Sorry for my English because it's some specific names and specific phrases that I have pronounced very clear for our audience, such as tsetse files and even moths. And this is another serious problem that lead to global food loss. And sometimes insects damage up to 40% of entire harvest. It's a huge amount, speaking about food, and so problem like a hunger. And we have the method that so-called the sterile insect technique, or SIT for short. This is the most environment-friendly control method ever developed. It has been used successfully in more than 60 years, and it's currently used in all over the world.
Yes.
And the International Atomic Energy Agency has been conducting the applied research for more than 5 decades and transfer solutions to the countries for use in agriculture. In the beginning, I mentioned about different methods of using nuclear technologies, and the main value of nuclear technologies is multi-purposeness.
Yeah,
And I
actually,
hope that a few examples that I mentioned help you to understand about this.
Yes, that's what I'm going to ask you. What about first of all, I think that it's really important that that we have such technologies for food saving because it's really vital in a situation, for example, of hot temperature, because the terms there are not much freezing in some countries, so it would really help. And so maybe let's talk a little bit about the goal number 3. I mean the good health and well-being, because another huge problem of today is cancer and other diseases. And what about this one? How nuclear technologies can help?
Yes, Paulina, you are absolutely right that you mentioned this huge area that is very important in our life, and especially with using nuclear technologies, it's health, it's our life. And let me remind you a few facts about nuclear technologies. For example, centuries, the doctors dreamed about opportunity to have a look into the body of the patient without cutting this, without surgery of this body. And in 1895, if my memory doesn't fail me, they were discovered the X-rays.
I know
And
this.
yeah, and the true and the dreams came true, because from that time it's very easier for doctors and very comfortable for the patient to get some kind of procedures, speaking about diagnostics and speaking about treatment and some procedures and services. And today the X-ray is absolutely an ordinary procedure. We use it everywhere, and we are very comfortable, for example, coming to the dentist or other doctor and having this procedure, having these X-rays absolutely calmly for us.
Yep.
No, how say, no protest for that, because we understand it. And by the way, this is the special radiation procedure. This is the nuclear technology. And speaking about X-rays, I can share with you some additional, additional benefits from that. That today, using the X-rays, and sorry, I forgot to mention that from discovering the X-rays, it was there was a trigger to create the new kind of equipment. The equipment that help people to to get the additional service, medicine service, and explained like the absolutely ordinary procedure. And a specialized area of medicine that uses the radiopharmaceuticals is called nuclear medicine. And nuclear medicine helps doctors to diagnose this on the first stages, some kind of, sorry for my bad English.
It's for cancer diagnosis.
For cancer,
right.
it's the main problem, of course, and
So
for cancer, it's
actually my mother
the most
did this.
very important to make a diagnosis, then the therapy and services using the radiopharmaceuticals. And now it's impossible to imagine healthcare system without nuclear technology, speaking about the positron emission tomography, radiopharmaceuticals used in procedures about the manufacturing of research reactors and produce radionuclides. A long list of special terms and topics, of course. And Rosatom developing the nuclear medicine from the production of isotopes to effective medical treatment for many years. I mentioned it just for your understanding. We are not just talking about these technologies. We are doing a special services and producing the equipment for that. It's our contribution to the sustainable goals. And which role does nuclear play in medicine? Probably me, working in nuclear cooperation, overestimate its role. Let's ask Paul Wayne, Chairman and Director General of the International Irradiation Association. Paul, what do you think? Are radiation technologies so important?
Actually, I guess.
Thank you, Boris.
Yeah.
Thank you, Boris. Can you hear me okay?
Yeah.
Perfect. I've got a few slides, so if the tech team could put those up. But in general, what we're talking about here is I would distinguish between industrial irradiation and nuclear medicine. And I think Giovanni is going to speak about nuclear medicine. I'm going to speak a little bit about irradiation technologies and the various applications. So I'd like to just take a few moments to talk to you about the applications of irradiation, a little bit about the technology, quickly about one of the alternatives, and then some of the environmental applications that these technologies can help to play. So the first point really is that irradiation is little known and even less well understood, and yet it affects all our lives on almost a daily basis. In fact, I would guess that most of the people present at COP26 will have come in contact with materials that have been irradiated on a fairly regular basis. The two biggest applications for radiation are the sterilization of single-use medical devices, single-use products. And the other one is cross-linking, polymerization of materials. So sterilization would be anything from simple bandages and blood collection tubes through to complex hip joints, prostheses of all sorts. So it's a vast array, and about almost half of all single-use medical devices used around the world are sterilized using radiation technologies. So a vast amount. And so the other big technology is the application is polymerization. So the cross-linking and degrading of polymer chains. And that goes into a vast array of materials. It's actually the biggest application. And so if you're using aircraft, aerospace, engineering, defense, automotive, rail, space exploration, all of those sort of things benefit from this technology. If you go into a greater array of products, you've just referred to sterile insect technology, and I think I would break down food radiation and phytosanitary as slightly different. So you can treat products for food safety, to avoid illness arising from microorganisms, and for food security, to prevent wastage. But the biggest application today, and the one that's growing the most, is probably phytosanitary, which is where you want to avoid the transmission of biohazards, of fruit flies and other contaminants from one region of a country or to another part of the world, another country. And that's quite a big area these days. And if you think of the concern that Australia would have if you're taking fruits into the country, it's the same. If you're moving product even within Australia, but bringing them from one country to another, you want to make sure that your borders are biosecure. So irradiation can play a role there. It can play a role in plastic, wooden flooring. By injecting monomers into and then solidifying them using irradiation, you can improve their strength and their resistance. A lot of polymers are processed in order to improve their resistance to heat, abrasion, solvents, and so forth, and therefore to make them safer. So it's a safety. Often this is to do with safety. Electronics are electronic components. You could be involved in hardening of electronics that are used in spaceflight, where they're exposed to forms of radiation, in high altitude flight, in nuclear reactors, and so forth. You can process gemstones in order to improve their color and therefore their value. So topaz, when you process it, changes from a sort of orange color to a blue. You can process blood. Blood is treated to prevent graft virus host disease in patients that are having blood transfusions. You can treat tissue, skin, bones, and amniotic membranes to reduce the infection resulting from allografts and so forth. In textile dyeing, one of the biggest problems today is wastewater contaminants of our waterways. And by using radiation technology, you can, in fact, 20% or so of all industrial waste globally is coming from the textile industry. So you can use irradiation to clean and separate the biological organic pollutants that are in the water. You can use it and cultural heritage to protect and save and the deterioration of items that could be wood, parchment, textiles, and so forth that could be damaged by bacteria and fungi that are present. So one of the most famous examples of that was Ramses II in 1977 was treated in France in order to stabilize it and protect it from deterioration. Gas treatment, if you're looking at flue gas treatment, so if power stations often are pumping out NOx and SO2 into the atmosphere, this technology can be used to reduce those pollutants by up to 85%. So and pharma, a lot of the good manufacturing practice requires the use of microbiologically clean ingredients in that area as well. So I could go on. There's a vast array of materials that's processed that we would come into contact with on a daily basis, whether you're sitting on a plane, whether you're actually having treatment in a hospital. There is something that is that will have benefited from irradiation. If we go on to the next slide, I'll just put this in perspective. When we talk about irradiation, this is ionizing radiation. There are two basic ways in which you can generate the energy. One is from a gamma source, which is cobalt-60, which is a specifically manufactured radioisotope that decays back to nickel about 150 years. It has a half-life of 5.3 years. So it's a specifically manufactured byproduct of using nuclear reactors for power generation. Or you can use electricity. So you can use electron beam or X-ray systems. And generally, gamma is the system that historically has been used for sterilization of medical products. Electron beam is the technology that's been used for polymerization, for surface treatments of products. X-ray is a relatively new treatment. I would argue that gamma probably has a lower carbon footprint, but it depends very much on the way that you're generating your electricity. But one of the problems with let's say X-ray is the rate of conversion, because you only get a conversion from power input to output of about 8 to 15% with X-ray. So it's each of these technologies are complementary. Each of them have their particular strengths, and therefore they're used extremely widely for the benefit of all these applications that I've just mentioned. We go on to the next slide. Go to the next slide. This one's, no, it's one back from there, actually. Should be another one. Alternative technologies. This is, if we look at, well, what's the alternative to the sterilization using irradiation technologies? So gamma, electron beam, or X-ray. And the main alternative that accounts for pretty well the other half of the sterilization capacity is ethylene oxide gas. Pre-1987, it was mixed with freons, CFCs, in order to treat the product. But in the Montreal Protocol in 1987, we wanted to restrict the use of greenhouse gases, CFCs. And so the technology could have actually been effectively outlawed, but it's so valuable in it complements what you can do with irradiation. And so the technology has changed over time. Concern then was about mixing it with CFCs. Now it's about ethylene oxide in it itself. And so there's a lot of work being done to reduce the concentrations of the gas and to clean the gas through scrubbers and abaters before you release it to atmosphere. So whatever technology you're using, if you want sterile medical product, you're going to have to use something that kills bacteria, and that's quite a harsh environment. I would argue that irradiation is a much better solution for the environment, but it can't do everything. So EO is also required. Next slide. So here I just want to touch on a few examples. There are many examples that scientists over the last 30, 40, 50 years have developed that actually can address environmental challenges that we face. I mentioned at the outset the wastewater. 20% of all wastewater is coming from the textile industry. China, using a company called CGN, put 7 accelerators together. This is in Guangdong province. It's connected with a textile manufacturing facility. Came on stream in 2020, and that's used to treat the wastewater before it's released into the oceans, into the waterways. Another example is in India. They're using gamma and electron beam. There's a number of facilities now where they're taking human effluent, human waste and sludge, and then through a hydrogenization process, they can stabilize that, they can remove the harmful bacteria and so forth, and use it as a fertilizer in the countryside. So those are two examples, but then you look at microplastics. There's been things that the IEA have been doing recently on that they're talking about 1/3 by 2025, 1/3 of the, well, microplastics in the oceans will represent probably 1/3 of compared to fish. And they believe that by 2050, at the rate we're going, there'll be more microplastics by weight in the oceans than there will be fish. So addressing and cleaning, and these technologies can help with that. Go back to flue gas treatments and so forth. You can use flue gas treatments, electron beams, and to actually remove NOx and SO2 from before it's released from these waste stacks. These things are not well used today, and I'm sure it comes down largely to economics, its cost. But there are solutions, and there are many different ways in which radiation technologies can help the environment. So the final slide is just a wrap up and to say, so I would just say that you're already coming into contact with the ways in which irradiation is helping the environment already. It could do a lot more. Thank you. Sorry to
Great. Thank you, Paul. That sounds really great, and looks like radiation technologies are really very much spread through our life. And my question is actually this radiation words is that are they really safe, these technologies? So I understand that they are very widely applied, and please share with us what's about safety and security, and probably if we remember about the Sustainable Development Goals, I have a question about the goal number 12, that is responsible production. So please, maybe you can cover this part of subject.
First of all, let me say thank you, Paul, and taking the opportunity, I would like to thank your association for supporting and promoting irradiation technologies. Thank you once again, Paul. And let me explain the additional area of using the nuclear technologies. I need my slide, my picture about Alex,
can you help us with the slides of Boris, just to put them on the screen back? So I think we can move on, and the slide will appear somewhere here.
Okay, I have already mentioned about X-rays, and
here are they.
Oh, yes, nice. Let me find the. No, it's too early.
Okay.
About industry, where the X-rays are using everywhere in the different areas. Maybe you haven't known about this, but generally having this opportunity to see inside the metal and through and penetrate through some kind of constructions, it's a huge assistance for producing different kind of equipment, especially if you have a very big forges and casting and welding constructions. It's opportunity to see and check the quality, to find some kind of defects inside and deep cracks in welding errors. And the irradiation methods and not destructive monitoring system helps in the construction of bridges, buildings, and other construction. And our specialists are doing it every day and everywhere in all fields of industry. And once again, it's a using of nuclear technologies. And this area of using can be as an additional and huge event to explain all kind of details. That is why let's indeed get back to medicine. Talking about medicine, as we mentioned, one very important area for nuclear technology, and I would say maybe the most important for nuclear technology, of course, it's a cancer epidemic. And I would say, experts discussed that the statistics by 2040, the number of new cancer cases will increase by almost 50%.
Yeah, that's really a huge problem all over the world.
Very big problem, and the nuclear methods play a crucial role in addressing the issue related to the prevention, diagnosis and treatment of cancer. And speaking about, once again, about Rosatom, we producing the different equipments and prepare some kind of services and using it everywhere and worldwide. But right now, speaking about different territories, we have our participator, Mr. Giovanni Gargoni, Director General of Regional Healthcare and Social Affairs Agency of Puglia in Italy. And my question to Giovanni, what will you say? What role does nuclear medicine play in Italy?
Hi, good afternoon, and thanks for inviting us and for hosting us. I want to thank Rosatom, iStop JSC, and COP26 organization. The role in medicine of radionuclides, radiopharmaceuticals, is huge, and I guess not all deployed, not all the capabilities, not all the possibilities are really till now employed and deployed on cancer treatment, even though in other diseases. I prepared just a few slides. Can you share my presentation? Okay, thanks. Next slide. First of all, who we are and where we are. I represent Apulia region. Next one, and next slide. And the regional agency for health and social care. Apulia region is a region located in southern Italy with 4 million people and with an annual healthcare budget of more than 7 billion euro distributed among 6 local health authorities, to research hospitals, to university hospitals, 33 private hospitals with public accreditation to operate, and more than 500 private social providers. Next one. Next slides. Thanks. ARES Puglia is the regional government agency and charged for innovation in health and social sector, and I mean product innovation, process innovation, knowledge innovation, and these are, you can see, our 4 main scale areas: epidemiology and care intelligence, epidemiological surveillance, big data analytics, and so on, technology assessment and scientific research, system innovation, social inclusion and innovation, and quality, healthcare quality. And the 4th one, e-health and digital health. Next slide. In terms of scientific care need, Apulia region is a typical region of a developed country. So with a huge prevalence of chronic illness. 4 out of 10 citizens are chronic patients, and they use almost 90% of a regional health budget. So a region aging, a region chronic ill, and as we try daily, hopefully a region active and healthy aging. Next slide. In terms of cancer care need, I report only few figures. Currently, we have in the region 180,000 citizens that live currently daily with a cancer diagnosis since 1, 2, 3, 4, 10 and more years. More of them are long survivor. And in terms of incidence, we have 22,000 5,000 new diagnoses of cancer annual, and each day, at the end of this day, 60 patients, 60 citizens will have a cancer diagnosis. Our rates are lower than the average of Italy, but it remains always not good news. Next slide. To face cancer and to take cancer challenges, we designed in 2017 a regional cancer network based on a comprehensive cancer centers framework and managed by a 3 tiers organization. A regional oncology council for strategic direction, at the second level, at the second tier, a regional oncology board for executive process, and at the first line, the patient line, 4 wide areas integrated cancer departments. Our cancer network has many points of excellence, many points of strengths, but it has also many weaknesses, and among them we can mention shortage of radionuclides for cancer treatment. We currently use radionuclides for cancer diagnosis. I mean, positron emission tomography and so on, also for neurodegenerative diseases. But we have a shortage of interesting and efficient radionuclides for cancer treatment. So in 2019, next slide, we signed a memorandum of understanding between Sechenov University, Rosatom, and Apulia region to pursue many common aims and objectives in cancer care, and among them also an experimentation carried out in September 2019 with lutetium-177. Lutetium-177 is an isotope used for prostate cancer. And as you know, or as few knows, space, distance, and time are enemies of radiopharmaceutical efficacy. So in Italy, where so many decades ago we made the choice to not to pursue nuclear energy provision, it's a gap. That's a gap to have closer the availability of interesting and efficient radionuclides. So we carried out this experimentation. Lutetium-177 made a journey long more than 5,000 kilometers in the form of semi-finished product. And from Ekaterinburg through Moscow to Warsaw till Bari, where the University Hospital Policlinico Radiopharmacy finished the product with a high standard of quality. Next one. Obviously, that's only a piece of the whole cooperation between Russia and the Apulia region. We have at least 3 common directions. First of all, radiopharmaceutical production for lutetium, for just mentioned lutetium-177, but also for actinium-225, used for prostate cancer, used for some forms of breast cancer and myelomas, And the second direction of cooperation, the strictly scientific cooperation for clinical research, and also the radiopharmacy profit enhancing, not only scientific research, but also development, economic and development and social development between the two countries. Lastly, lesson learned. Lesson learned. First of all, distance, according to our prime experience, we can see that distance is no more a constraint, that nuclear waste is an interesting health resource, but at some conditions. And the conditions resides all in the term mostly used in these days. And the term is ecosystem. In COP26, we talked about climate ecosystems, but there are also economic ecosystem, social ecosystem, and industry ecosystem, and innovation ecosystem. And they are all the same gear wheels related. So only if we think, design, implement, and manage in terms of ecosystem and outcomes ecosystem instead of product of a single provider, we can use all the possibilities of the radionuclides, both for the cancer diagnosis and for cancer treatment. That's all for now. Thanks.
Yeah, thank you, Giovanni. That was really impressive, and I really like your idea that these nuclear appliances, they are much more wider than only about climate. It's very important that we have a solution to save lives, for example. So, Boris, the floor is yours now.
Yeah, thank you once again, Giovanni, for your contribution, for your attitude, and generally for your work. Because our health, I think, is the most important thing that should be or can be in our life. The other changes, climate and agriculture, is like a supporting areas of our life and our health. And nuclear technologies save lives, help people to live longer, and generally it's a huge benefits. But at the same time, it's additional issue to achieve the sustainable development goals. Why? Is the question. And the answer is so complicated. And I would say the combination between question and answer. We have these technologies, but it's very difficult to achieve the benefits. And my personal understanding that the problem is that we have to inform. We have to have the conversation with different people, with different group of people, to explain about the useful of radiation technologies, their safety, and we have to change our attitude for them. We have to use it and develop these technologies for our life, for increasing the level of our life. That is the main idea, and I'm absolutely sure that we have to continue the same conversations on the different floors with different people, or for some people maybe to repeat and having some kind of answers for their questions, because I am absolutely understand that information about nuclear technology should be absolutely clear for the ordinary people, for all of us. And once again, the nuclear technology help in our life and do our life much better.
Yeah, here we have the goal number 17, that is about the partnership and communication and transparency. And so, yes, that's very good that nuclear industry has become nowadays quite open and communicating widely.
That is why we are here,
yes.
trying to explain the additional
Yeah,
information.
that's right.
And by the way, please do not be too hard on me. I am not a professional in medicine and maybe in, how say, in the atomic nuclear, speaking about this like a fundamental science, but I try to explain the information on the common level, like you, to share with you what I know, and I hope you know now.
Yeah, thank you very much. And thank you very much, Paul and Giovanni, and thank you very much for your listening. And now, actually, I think we have a time for one or two questions. So please, yes, please, we have a microphone here.
Thank you so much. My name is Kyle, and I'm an observer from Indiana University, from the USA. And Boris, at the end, you talked about the need to explain to the public the benefits of these technologies. As for the non-energy aspects and also for nuclear energy as well, how do you think we can best go about explaining to the public the benefits and trying to show all the good that nuclear can do?
As I understood right, you asked me how it's better to explain to the population, for the citizens, for the people. I think it's like we do right now, to organize some special events and having the opportunity for our questioners to ask, first of all. It means we should be open using websites, exhibitions, conferences, direct questions to our company, for example, because we know a lot of this technology, we produce the equipment, and that is why it's, I would say, it should be like a task, first of all, for us to share with you and organize this communication, and using the common examples from our life, share this information with our experts that can prove the real practice in the different areas: agriculture, medicine, industry. For example, having a lot of enterprises and machinery building companies in our company, our divisions, we use the X-rays and these methods of radiological control every day in different areas. And we absolutely ready to show you. And we have a group of people visiting our enterprises to see our processes. And that is the additional opportunity to be opened and to be ready to explain everything about these technologies. I think this is the method, to be opened and ready to explain on the different levels, non-professional, on the professional level.
Yeah.
Have I answered?
Yes, thank you.
Thank you
Great.
for your question.
Thank you very much. I think that we have run out of time a little bit. So probably
Maybe for last question, if anybody has.
one more question we can take, and so do. No. Okay. So here we are. Thank you very much. Thank you very much again.
Thank you, colleagues, once again.
For your participation.
Our pleasure to see you and be together in this conversation.
Yeah, and by the way, I think in 10 minutes we will continue our presenting of nuclear technologies appliances, and there would be there would be presented quite an interesting, to my opinion, project about these radiation appliances in Africa, in South Africa, for Renatop. So it's really very impressive experience, very impressive project. So please, if you have some time, please stay and enjoy this project presentation. And thank you for your attention. Thank you very much.
Thank you. Включаем? Я думаю, что мы можем.